A warm good afternoon to all. This lecture is about Rockwell hardness, which is the last type of hardness test. So this Rockwell hardness is another widely used method for measuring the hardness of the material, especially metals, as like other hardness test. This hardness test measures the depth of the penetration of the intender into the material under specific loads and often preferred for simplicity, speed and versatility. And here this selection, the first significance of this Rockwell hardness is that selection of scale and intender. The Rockwell hardness offers several scales, example as A, B and C. Depending on the type of material hardness range being tested, each scale is used in different combinations of intender type and loading. For example, if you are taking a Rockwell A, that is HRA, is used a 60-degree cone shaped diamond intender and especially used for soft materials like plastics, aluminum and copper alloys. If we take a Rockwell B, is used as hardened steel ball intender and commonly used in the material like brass, aluminum and mild steel. If we take a Rockwell C scale, it is HRC, is used in diamond cone shaped intender and suitable for harder material like tool steel, hardened steel and alloys. The second one is application of preliminary load. The preliminary minor load is applied to preload the intender into the material surface that ensures proper contact and stability. The third one is application of major load. A major load is applied on the material causing the intender to penetrate to a specific depth. The major load is maintained for a predetermined dwell time to allow for accurate measurements. The fourth one is removal of major load. After the dwell time, the major load is removed and the another minor load kept on the intender in contact with the material. Measurement of indentation. Here the depth of indentation made by the intender is measured using a dial gauge or electronic sensor. The difference in depth, the initial and final position of the intender represents the Rockwell hardness value. Here the hardness value is directly taken from the calibrated scale based on the depth of the penetration and the specific Rockwell scale being used. Taking into the consideration of the other its advantages over the other hardness test is that it is more speed and simplicity, which because it is relatively quick and easy to perform and requires minimal sample preparation and operation time. But it is not as like that in Vickers or Brenner. The second one is that the test can be used on a wide range of materials, some from soft plastics to hardened steel, by selecting the appropriate scale and intender. Here this Rockwell hardness test typically provides constant and repeatable results when performed correctly, and we are in the previous two types of hardness test we have to use a formula, the load applied, the intended area by load applied, in order to have the hardness value. But here in this we can take the value directly. So here the other important thing is that the hardness this Rockwell hardness typically provides a constant and repeatable results when performed correctly and allowing reliable comparisons between the different samples and test conditions. Unlike the Vickers hardness, which is used pyramid intender, Rockwell uses a ball or cone shaped intender where they produce a large contact area within the material surface, which features reduces the influence of surface roughness and provides more representative hardness measurements. Overall, combining the speed, versatility, non-destructive nature, easy of use makes the Rockwell hardness is one of the predominant hardness test and is used as a valuable tool for assessing the hardness of the material in various industrial applications. It is also used in sectors such as manufacturing, automotive, aerospace, constructions for quality control, material selection and process optimization. Moreover, this Rockwell hardness test is used to assess the material properties, especially hardness, And moreover, when compared to the other harnesses, we can say, in short, we can say Brunel is using higher load areas, because it's using it's otherwise called as micro harness, where very low load is used. The third one is Rockwell, which uses 3 types of scales, but the reading can be taken directly from the